beta and gamma function. Beta function can be written as beta of m comma n equal to integration 0 to 1 x power m minus 1 into 1 minus x power n minus 1 into dx. Here m and n should be greater than 0. Here we can interchange the value. We can write it as beta of m comma n as beta of n comma m also. There is no changes. Similarly, we can write the modification of this one. So let us consider here 1 minus x is there. If we write it this as 1 minus sine square x, and then we can write it as cos square x, we can modify. So here let us consider x equal to sine square theta. So here if we differentiate this one, we can write it as 2 times sine theta, and differentiation of sine theta is cos theta with respect to theta. So here we must change the limit. If we put x equal to 0, lower limit x equal to 0, sine theta is 0. That is theta is 0. Here x is 1, sine square theta is 1, sine theta is 1, taking square root. When will you get theta equal to 1? Sine 90 degrees 1. So here this one we can write it as integration 0 to pi by 2. X is nothing but sine square. Here m minus 1 is there. We put the bracket m minus 1 into theta. 1 minus x is sine square theta power n minus 1 into dx. Dx is 2 times sine theta into cos theta into d theta. So here power we multiply integration 0 to pi by 2. This 2 we write it before the integration. This one we can write it as sine power 2m. Multiply this one 2m minus 2. Then this sine n theta is multiplied here. That means power should be added. And here this can be written as cos square 2 power n minus 2 theta. Here cos theta is the plus 1. So if we simplify this one, we can write it as 2 times integration 0 to pi by 2 sine power 2m minus 1 theta into cos power 2n minus 1 theta into d theta. This is the alternative formula. This is alternative formula. So we must remember both the things when we discuss the beta gamma function. Definition of gamma function. So here gamma n, we can write it as integration 0 to infinity e power minus x into x power n minus 1 into dx. N is greater than 0. So this formula is helping when we discuss the Laplace transformation. So here we can write the alternative formula of this one. So let us consider, we consider x equal to t square. So here gamma n equal to, here x is 0, x is 0, t also 0, x is infinity, t also infinity. So the limit remains same, e power minus t square into t power 2, and then we put the bracket n minus 1 into dx. In differentiation of this one is 2t into dt. So 2 is taken out, 0 to infinity, e power minus t square. If we add this one, we get 2 power 2n minus 2. Here t power 1 is there, plus 1 dt. We get the answer 2 times integration 0 to infinity e power minus t square into t power 2n minus 1 into dt. So let us consider this as equation number 4 and 3. Remember the equation 1, 2 in beta form, gamma 3 and 4, which helps when we discuss the problems. We prove gamma 1 by 2 equal to pi by 2 using the definition. So here we have the definition. We write the alternative form of a definition. So here gamma n, we can write it as 2 times integration 0 to infinity e power minus t square is there, we can write x square, x power 2n minus 1 into dx. So this is the alternative formula of gamma function. Here n is 1 by 2, so we can write it as gamma 1 by 2 equal to, here n is 1 by 2. So we substitute in the right hand side. If we substitute, we can write it as x square, here x power 2 into 1 by 2 minus 1 into dx. So here 2 get cancelled, we get 1, 1 minus 1, x power 1 minus 1 is 0, x power 0 is 1. So here this one we can write it as 0 to infinity e power minus x square into dx. So we consider this as equation number 1 for this problem, and once again we write gamma 1 by 2 by changing the variable. Here straight away we replace the equation number 1, we get e power minus y square into dy. Now we cannot find out the answer using this one, so we are taking the alternative form. Now we multiply this one, gamma 1 by 2 into gamma 1 by 2. So here if we multiply this one, we can write it as 0 to infinity e power minus x square into dx, integration 0 to infinity e power minus y square into dy. So here this one we can write it as, here 2 times is there, so 4 times integration 0 to infinity into 0 to infinity. Here base is e, minus we take common, x square plus y square into dx. Now we must integrate. So here we use the polar coordinates. Let us consider, let x is r. So we know the polar coordinates. X is r cos theta, y is r sin theta. If we square and add this one, square and add, we get x square plus y square equal to r square. So here If you put x is equal to this one x and this one is y, here x square plus y square equal to r square is the circle. We must express in terms of x and y. So here this is circle, center is radius 0, and we are getting this one as upper limit r square. R square is depending upon the value r. So here upper limit is infinity is there, x and y. So limit is 0 to infinity. Theta is nothing but this is first quadrant. So here x is 0, x is infinity, y is 0, y is infinity. So this belongs to first quadrant. R is, if we draw the circle, 0 to infinity is the limit for r. Similarly, theta in the first quadrant, theta is 0 to pi by 2. So here this integration, we can write it as 4 times integration theta is 0 to pi by 2, integration r is 0 to infinity e power minus x square plus y square is nothing but r square into dx is there. So here we must write dx into dy. Dx into dy is nothing but r into dr into d theta. This one we are getting using the Jacobian. So here Jacobian is what? X is r cos theta, y is r sin theta. That is dou of x comma y dividing by dou of r comma theta is nothing but differentiation with respect to r. We get cos theta and sin theta. With respect to r, minus r sin theta into r cos theta for y. So here if we find the Jacobian, we can write it this as r times cos square theta plus sin square theta. So this is nothing but r. We cross multiply this one. Dou x dou y is nothing but dou r theta. So this is nothing but we are writing as dx dy equal to dr d theta. So here we can write it this as gamma 1 by 2 whole square equal to so here we consider let r square equal to t. If we differentiate this one, we get 2r dr equal to dt. So here we substitute this one. 4 times integration theta is 0 to pi by 2. Here limit remains same. E power minus r square become e power minus t. And r into dr is there. Here we have r into dr. It is nothing but dt by 2 into d theta. Here we can cancel these two and we integrate with respect to t. Integrate 2 times integration 0 to pi by 2 e power minus t is e power minus t dividing by minus 1. Limit is 0 to infinity. So here if we integrate upper limit, we get 0. E power minus infinity is 0 minus, here denominator minus is there, plus e power minus 0. So here if we differentiate this one, this is 0, this is 1. So integration of this one is nothing but 2 times integration 0 to pi by 2 d theta is nothing but 2 times theta. We apply the limit 0 to pi by 2 we get the answer 2 times pi by 2 is nothing but pi. So what is this one? This is nothing but gamma 1 by 2 whole square. We take the square root of this one. Gamma 1 by 2 is nothing but square root of. So here this is nothing but gamma 1 by 2 is nothing but square root of pi. Proof of relation between beta and gamma function. So here beta of m comma n equal to gamma m into gamma n dividing by gamma m plus n. So here we check that whether we get the same proof. Here we write the definition of beta and gamma. So here we write the alternative formula of beta of m comma n is nothing but twice integration 0 to pi by 2 sine square 2 power m minus 1 theta into cos power 2 n minus 1 theta into d theta. So we consider this as equation number 1, and here we write gamma n definition is nothing but alternative formula twice integration 0 to infinity e power minus x square into x power 2n minus 1 into dx. And gamma m, we change the variable, we write it as 2 times integration 0 to infinity e power minus y square into y power 2n minus 1 into dy. So here gamma m into gamma n is there in the numerator. We multiply the term gamma m into gamma n. So it is nothing but 2 2s are 4. We have the limit 0 to infinity integration 0 to infinity e power minus, here power we can write it as x square plus y square, and here x power 2n minus 1 into y power 2n minus 1. This is m. So here this one m is nothing but here m minus 1. Then we can write it this as x power 2n minus 1 into y power 2m minus 1 into dx into dy. So here e power minus x square plus y square is there. This is x square plus y square is nothing but circle. So here we are getting the first quadrant. So already we have discussed this one. This is nothing but so here x is 0 to infinity, 0 to this one is infinity, and y is 0 to infinity. Both are positive, so we must consider this one. So here theta is 0 and theta is pi by 2. So here x we must consider r cos theta, y is r sin theta. So here we are getting r is 0 to infinity, theta is 0 to pi by 2. So we substitute these things in equation number 2. So here if we substitute, we can write it as integration 0 to infinity e power minus x square plus y square. Here if we square and add this one, we get the circle, that is x square plus y square equal to r square. So this is nothing but e power minus r square, and here x is r cos theta power 2 power n minus 1, and y is r sin theta. Write it in terms of bracket, and here dx is nothing but, so already we have discussed this one, dx and dy together we can write it as r into dr into d theta by Jacobian. So r into dr into d theta. So here we split the power. So here we have the limit theta is 0 to pi by 2. So now we write r1 to r1 side and the theta one side. So here e power minus r square. Here we split the power, r power 2n minus 1. Here cos theta is the cos power 2n minus 1. Similarly, r power 2m minus 1 into sin power 2m minus 1 theta r into dr into d theta. Here limit is 4 times 0 to pi by 2, 0 to infinity. So here now we write r together, integration 0 to r, limit is 0 to infinity, e power minus r square, r power, here we add this power 2 power n minus 1 plus 2 power m minus 1 plus 1. And we write the theta now. Theta is 0 to pi by 2 sin power 2m minus 1 into theta cos power 2n minus 1 into theta into d theta. Here 4 is there, we write it 2 into 2. So here we have written the equation number 1. So equation number 1 is 2 times 0 to pi by 2 sin power 2 m minus 1 into theta into cos power 2 n minus 1 into theta into d theta is nothing but definition of beta. So this one we write it as, this one is nothing but beta of m comma n. Left hand side we have gamma m into gamma n. Here we simplify the term, 2 times integration 0 to infinity e power minus r square into r power 2. Here if we add this one and this one get cancelled, we get 2 power m plus n minus 1. Here we can write twice m power m 2 power r square into m plus n minus 1. So here we know that gamma n is nothing but twice 0 to infinity e power minus x square into x power 2n minus 1 into dx is the definition. So here x is nothing but, here we have n is nothing but m plus n is there. So here this one we can write it as gamma m plus n into beta of m comma n. So here we modify this one, beta of m comma n, we can write it as gamma m into gamma n dividing by gamma m plus